collarbone. Yeah, go and record if you haven't not recorded already. So look for your collarbone right here. You might look at it and say, oh, I don't know how to tell left from right. Well, it's actually not that bad. I may go grab that one if I don't see it, but did you guys see this little quiz over there where it has a bunch of examples of name the bone and tell me what side of the body it's from? Clavicle is one I've used before, that's why this one's up there. Here we go. All right, so this is a clavicle, this is a collarbone. And things you need to know about it. If you look at it, it's not the same on all sides. What was better, me back there or me up here?
I think up here.
Okay, that works. All right, so first I want you to notice there's an end that's kind of flat and an end that's kind of chunky and big. You see the difference? The chunky one is towards the middle. Good? Now, so you know this is going to the middle, but do we go like this or like this? Do we go like this or like that? How do you know? Well, the flat goes laterally. Good? If you look at the way it's curved, if you look at the actual skeleton, this is curved back towards the shoulder, back and then comes out. So, chunky in the middle has to be like this, because we have to have this curve to get to the flat. Does that make sense? But there's another thing to let you know, much faster. You pick up a clavicle, a human clavicle, and you look at it. There's the chunky for the middle, there's the flat for the lateral, but there's a point. You guys see this point? Let me put it right here so we can see what I'm talking about. This might be better to be doing, let me see what y'all think. Definitely going to be easier. Okay, let's do it again. Yeah, okay. We're going to close and restart. I'm sorry. Yes, restart. What I meant to do was expand it, and I hit the wrong button and closed it. All right, so here is a clavicle. Can you see that well? Would you do me a favor and turn the light off and then turn it on? I just learned how to make it a little brighter than normal. I'll make it a little, turn it back on. That's a little dimmer. Can you see the screen better now? Yeah, okay, so take a look at this. Right here we have the chunky end, the kind of round end, that's the medial. We have the flattish end, that's the lateral. But look on the flat side. You see this point right here? Yes? That point is down. That point is down and it's to the back, it's to the posterior of the clavicle. So this is a right clavicle. Does that make sense? I'm not saying a long nod, y'all with me? So you know medial from lateral, the medial to the middle is kind of big and round, lateral is flat, and you know the point is on the bottom. So if you're wondering which way, the answer is point on the bottom. If you're wondering which way, point is to the back. Good? Yep. All right, so we've done clavicle. We've done more than dramatic flourish. We've done more than our study guide said to know about clavicle. We've got that. All right. The next thing is the scapula, the shoulder blade. And here we have one that's all marked up. Here we have one that is not. This is the scapula. There are a couple things I want you to notice on the scapula. The most important one is this raised ridge across the back. That's called the spine of the scapula. Good? All right. Now, we'll talk about the other features on the scapula with the clavicle back. We look at this, and it has some things that we're supposed to go over. In the scapula, we're supposed to talk about the acromion process. That one's easy. That is this. You look at the scapula, you look at the spine of the scapula. Remember, the spine is posterior. The spine is to the back. Everybody clear on that? All right. So the spine is sticking posteriorly to the back. The end of the spine, that big, wide, flat area, that is the acromion process of the scapula. It's the lateral end of the spine. Good? Now you know it's lateral because it's above this. Sorry. It's above this right here. This is the ball, the socket of your ball and socket for the shoulder joint. It's called the glenoid fossa. So you know that is lateral. You know the glenoid is lateral because it has to connect to the arm, right? So if I ask you what side of the body this is on, it's pretty obvious. It can't be this because there's nowhere to put an arm. It has to be this side. Does that make sense? So this is a left scapula. You know that if you know that that the spine points posteriorly and the glenoid and the acromion are laterally. Good?
What side points posterior, you said? What is the piece called?
This spine of the scapula points to the posterior. Here, let me point to it on this skull, on this skeletal without the marking. This is our scapula. This is the spine of the scapula. This end of it is the acromion process. Good? Okay. This is the glenoid. That's the socket for the ball and socket joint that makes the shoulder. Are we good? Mm-hmm. All right, let's see what else is on this list that we need. Oh, this was really good. This was really good. I didn't even have to look it up. This. Let's see if we can, there we go. That shows it pretty well. What do you guys see? What's this look like? Oh, come on, people. This, right here, I'll give you a hint. When we talked about, last week, we talked about the jawbone and the big sticky uppy ramus, and then it had the mandibular condyle, right? Okay. And it was rubbed against the mandibular fossa on the skull. And then we had a point that I said looked kind of like a bird beak. Do you see this looks kind of like, there's a good angle, an entire head of a bird? Do you see it? Okay, so we're going to name it the same way. This, there's the head, there's the beak. To me, that looks kind of like a thick-billed raven. Not that you guys care that much about different types of birds, but it looks like a bird. And what they call it is the coracoid process, which means raven. Okay, it looks like the head of a bird, so pretty straightforward. Are we good? Mm-hmm. So the one, if you don't remember, the one on the mandible was the coronoid, and the one on the scapula is the coracoid. They both mean raven. I don't know why they split that way. Yes?
Is there a reason in our book it's called the acromion and not the acromion process?
No, but I can tell you what I'm going to be looking for on the test, and it's what I was told you to teach in the study guide. I doubt there's a reason why, but we're going to go for what they told me to teach y'all.
Thank you.
So, okay, upper arm, we're going to talk about the humerus. So we've got our scapula, we're done with that. Let's get our humerus. All right, here's our femur. Here's our other femur. Here is our tibia. Our two fibula. I bet there's a humerus up there on the ground. Oh, here's the humerus. That was funny. Aha. Okay, never mind. Remember, if you don't laugh at my lame jokes, I will try harder. I'll make everyone miserable. All right, so here we have a humerus. Everyone good with that? All right, humerus, ball and socket joint. This head, this is the ball and socket joint. Good? Fits into the glenoid fossa. Now, the head, we already said, is this piece right here. Good? Now we have the tubercles. We're going to have a greater tubercle. Let me pull that up, and you will see greater tubercle, and just a little bit lower is the lesser tubercle. So you can almost, it's a little trouble, but you can almost pick the humerus up by the greater tubercle. The lesser, it's a little too small to do that easily. Does that make sense? But greater tubercle, lesser tubercle. All right, so we've got those. Surgical neck. Why surgical? Well, two things. The neck is below the head. Oh, this makes sense. Surgical, if they're doing a shoulder replacement, they're going to cut the whole head off and drill into, they'll screw into it a replacement, synthetic replacement. Probably steel with Kevlar. I'm sorry, what is it, Kevlar? Steel with Teflon for the movement. Okay, so everybody feel good with that? I feel like I should grab my flat book, but we'll just keep going. So far, we're fine. All right, the capitulum and the trochlea. This is a little weird, so we're going to do it. I'll show it to you, and then I'll turn it 90 degrees. The distal end of the humerus here, we have a lot of articulation on. This is the trochlea, this is the capitulum, okay? Now, let's look at it here a little closer. Capitulum, trochlea, all right? Now get ready to use your imagination a lot. I'm going to try, let's see if this will work. Trying to hold it at a certain angle. There we go. Yep. That'll do. All right. Much better. All right. This example is going to seem weird to most of y'all. If you have any friends who are very into cosplay, it'll make more sense. Okay. So, those are dressmaking forms for cosplay. Use that picture. Let's just use that. All right, so you see it, yes? Some of them, some dressmaking forms, I should go for a smaller picture. Yeah, that's smaller, that's an angle. You see how this one can be expanded to different sizes? Yeah, that's what I'm getting at. Some of them have that option. Some of them have, actually have heads on them, so you can work on a fancy hat to match the dress that you're working on. But let's draw an outline of this dressmaking form. Let's say you have a head. You with me? Okay. It's not exact, but it's close enough that it reminds me, okay? So this is your capitulum. Oh, and the head, which is round, kind of like the letter C, might help you. Okay, and then we have the form, the dressmaking form. That would be the trochlea. You with me? Okay. So you can see the distal end of the humerus has a capitulum, the rounded area, and the trochlea right there. Everybody good? Now I'm going to jump ahead. I'm going to steal my own thunder. This is an ulna. You're going to hear this again and again. In bones, we tend to name things for something they touch. We did that twice in the skull. We talked about the zygomatic process of the temporal bone that reached forward to touch the zygomatic bone. Yes? We talked about the palatine process of the maxillary bone that touches the palatine bone that makes up the rest of the hard palate, right? Okay? This on the ulna is called a trochlear notch. You probably guessed it goes on the trochlea. This is the example we used in class where the shape of the bone helps stabilize the joint. You see there's a groove, I should say a ridge. There's a raised ridge right here in the trochlear notch. You agree?
Mm-hmm.
It fits into, move that up, there we go. It fits into the waist of our trochlea. Make sense? Yeah? Okay, oh, and this, the big thing on the end of the ulna, the back of your, oh, I hurt my funny bone. That's the olecranon. That's the anatomy name for it, the olecranon. On the humerus, on the distal end, on the posterior side, we have the olecranon notch. You see it? Yeah? Okay, so let's talk about this. One of the things over there that I've used before, tell me what bone, tell me left or right. I've used the humerus before. If you look at the proximal end, you can absolutely tell me medial where the head is and lateral away, right? But if you look distally, you can figure that out too, because the capitulum is on the opposite side of the head. The capitulum is on the lateral side. Are we good? And the trochlea right here, the bottom where the hips would be is medially. Oh, also there's another thing. We're about to talk about here we go. Let's just get to it. All right. What is a condyle?
Rounded surface.
Very good. On page 106, they added one thing. By the way, I said it last week, I'll say it again this week. Memorize everything on 106. Okay? Yeah, it's just a table that you need to know everything for. It's on the left page, left side. Yeah. A condyle is a rounded articular surface. Epha means above. So, would you agree here, this whole trochlea thing, it's a type of condyle. It's got roundedness, especially the capitulum, but it's articular surface, yes? Above it, we have, let me move this over. Above it, we're going to have the epicondyles. This big thing right here, that's going to be an epicondyle. This smaller, but it's still there, bump, that's going to be an epicondyle. You see it? They're above the articular surface. Those are epicondyles. How do you know medial from lateral? I'm going to tell you something that is true most of the time, not all the time, but it's definitely true in this case. Do you agree there is a difference in size between this one and this one? Yeah? Usually, the massive one is the medial one. And in this case, it is. You know it is because it's on the same side as the head. Good? So, lateral and medial epicondyles. We've got that. Let's see if there's anything else we haven't done. We did the head of the humerus. We did the greater and lesser tubercle. We did the surgical neck, the capitulum, the trochlea, the medial and lateral epicondyles. the olecranon fossa in the back where the olecranon goes. I call it the olecranon notch. They want us to use fossa. But you guys are good with that. We've done all the things on the humerus. You agree? All right. Those are very faint nods, but I did them. All right. Now, there are only 3 things they want you to know on the radius. Let's grab us a radius. We got olecranon, we got fibula, fibula. Here we go, this will do. We've got a radius. Now, when you hear the word radius, you probably think of circles, right? At least I hope you think of circles. Like, it's just sitting here, so we'll use it. There's a washer, it's round. You could measure the radius on that, yeah? Here is the proximal end of that bone. It's round. You could measure a radius on it, right? That's why we call it a radius. Good? All right. The head of the radius is this rounded proximal end. Everyone good? All right. Now, the next thing you need is the radial tuberosity. And this is easy. The tuberosity is a swollen area that sticks out, usually kind of rough. Now this one happens to have glue on it for a reason. Now this model, all the reds are origins and all the blues are insertions. Good? So here we have a big swollen area. You see it? We turn this at different angles. You see this big swollen area. It's narrow here, it's narrow there, and it's big and swollen in between. That's our radial tuberosity. Good? Yep. All right. And the next one, do you remember on the skull, there were some processes sticking down, not the big mastoids, over the smaller ones. Like where else were? Styloid, very good. And a styloid was to remind us of a stylus, a writing instrument. So it tended to be pokey and sticking down and up. We're going to use the same word. We're going to have the same thing happening, but not very well. Like the stylus, the styloid process on the skull really looks like a stylus. This one is very much in the use your imagination. Okay? So, a stylus is very pointy, very narrow. The styloid process, you can see it right there. It sticks down and it's kind of pointy, but from some angles it's a little more pointy, but it's not super pointy. Let me put the ball point back in. You would agree that from this angle you could almost see why they call it a styloid process. But the sticky down, kind of pointy end of the radius is the styloid process of the radius. Good? And that's the way you would want to write it on the test. Of the radius, make sure, because there's more than one styloid process, it's not good to write down styloid process and leave it at that. Because I'm like, do they even know what bone I'm looking at? Well, write the whole thing, styloid process of the radius, there's no question. Does that make sense? Yeah. You look skeptical, but it's the way it is. Okay. Let me say it another way. If we want full credit, we should put all the stuff down. Hey, have we gone through all 3 of the things on the radius that we need to know? I think we have. Let's now do the ulna. Oh my God, I have an ulna here because we were doing that before. So, we need 3 things on the ulna. The olecranon process, the trochlear notch, the styloid process. Oh, well, we already did some of these. The olecranon is this big chunky area. It's the back of the elbow that you bump, right? Okay. It goes into the olecranon fossa, which I like to call olecranon notch, but they don't want that apparently. This is the notch, and this is the fossa, and this is the olecranon that I'm holding the bone by. Good? So that's our olecranon. The only thing left is this was actually better. Narrow, sticky, downy kind of stylus. You with me? That's your styloid process of the ulna. Everyone solid so far? Yep. Okay, let's move on. the carpus, this is the hand in total. Talking about both the carpal bones and the metacarpal bones and the phalanges. So let's go over these really fast. I should have gotten out my lab manual because the picture is kind of rubbish. Sorry, because, oh, wow. This model does not suck. I'm still going to get out the picture, but the models that I had on North Campus, instead of being held together with springs so the things are tight, they're held together with drilled fishing line, and they kind of, anyway. So here's the deal about carpal bones. Up until the fall of this school year, we just did and these are the carpal bones, you'll need to know the carpal bones. Well, it wasn't really useful. Some other colleges I've been at do the really extreme and hardcore about it. They're like, know the names of every carpal bone. We kind of split the difference. What we did, there are 8 bones, and you have to know some of them, not all of them by name. And we did it for a reason. They weren't just randomly chosen, oh yeah, we'll use that one, we'll use that one. What they chose to use are the ones that are most frequently broken, those you need to know the names of. That seems like a reasonable thing. We can say it another way. You have to know the ones that usually have a clinical significance. All right, but let's look at our list. And our list says total of 8 bones, but we need to know the scaphoid, the pisiform, the triquetrium, and the hamate. Now, all stupid names. We can talk to you later if you want to know how veterinarians do it. It's much better, it's much easier, but that doesn't matter. Let's start with the easiest one. If you were to look at this, and both of them aren't showing it well, but we'll show you the picture in the book after this. Here we have the carpus. And everybody, anatomical position, yes. Thumbs to the outside, little fingers towards the leg. All right? The proximal row, most lateral, that's the pisiform. Okay? And so let's look at the picture, and then we'll look at it on the actual bone. And what I'm trying to say, oh, this is not a great model, blah, blah, blah. You're going to see they actually drew the 2 pieces together like it was one bone. So I'm looking at a picture or drew it. They actually made it. This is 149, okay, so 149. And you can see on 149, this one that they are calling the pisiform, and they have it labeled correctly. All right, this is the pisiform, and it's right there. You agree? Yes? All right. Now let's look at it on the model. I'm going to use the marked up one, so where everything rotated the same way. Oh, sorry. Everything rotated the same way. And you can see, here we have the thumb, here we have the thumb, yes? The shorter one, yeah, okay. So here we have our pisiform. Here we have our pisiform. Oh, you can't see it. There we have our pisiform. But notice, they're drawing it fused to another bone. A lot of times this is a free bone on its own. That's your pisiform.
Move it up.
Oh, sorry.
Okay.
A lot of times this is a free bone by itself. That's a pisiform. Are we good?
Mm-hmm.
So it's little, it's lateral, it's tiny. In some animals, like a dolphin, it never even ossifies most of the time. It's just left as cartilage. All right, so that's a pisiform. And the next one on the list, triquetrium, scaphoid hamate. Well, the hamate will be a solid, easy one we'll do the hamate next. I like that one, that one's easy. This is our hamate. See right here, this is hamate. I'm gonna put on my glasses so I can see where I'm pointing better. But the hamate, if you look like that, that's better. You see kind of a triangular shape to the hamate? Yes?
Mhm.
Okay. So, what we are looking at is our, that makes me unhappy. But this, you can see a ridge of some kind. It's not a ridge, it actually is a piece that sticks up. This, I'll put it right next to, if I zoom out a little, that might be easier. You guys can see both the drawing and the actual model, yes? You can see this right here, this triangle. We're talking about this right here. Do you still see the triangle shape? Okay. This is how you remember that that's the hamate. We're looking for a cartoon drawing of a ham. See the triangle? Yep. So this shape is a lot, let's pull that one up. No, not now. This shape is a lot like the hamate. It's got the triangle going. Everyone good? Yep. So we've got that. Now we have to do our scaphoid, which this is annoying because it's also a giant ham shape, but we're going to go for only from some angles though. The scaphoid is the one right here on the thumb side, which in the anatomical position, that's to the lateral, yes? Okay. This is our scaphoid, right there. And look at the thumb, you have the proximal row. I'll put this behind it so it's easier color contrast. This is our scaphoid. And then some angles, I'll turn it. That's from that angle, that's kind of ham shaped. You would agree? Yeah, that's the scaphoid. So the hamate is here in the distal row, the scaphoid is in the proximal row on the thumb side. And the last one, sorry, of these, we have, triquetrium. Okay. And triquetrium is, I should have done that one next. You agree this was the pisiform from the drawing of the pisiform, yes? And it was attached to another bone. That was the triquetrium. This is triquetrium. Are you with me? So those two together, pisiform and triquetrium. Which, by the way, that makes for a convenient type of question on a test. You know, because they're right there. What is this piece? What is this piece of this one bone? Okay, so we've got through the carpal bones, well, the ones that you need to know. Other parts, these are your carpal bones, the collection of little bones here. Coming off of them, we have metacarpal 1, metacarpal 2, metacarpal 3, metacarpal 4, metacarpal 5s. The metacarpals are these long bones, and the thumb is special. The thumb moves the metacarpal. Here, I'm going to pull this away so everyone can see better. Put my thumb back in just a minute. Here we have a hand. And would you agree the base of the thumb is down here, yes? At the carpus? That is because part of the thumb is the metacarpal. Metacarpal 2 goes from there to there. Metacarpal 3 goes from there to there. Metacarpal 4 goes from there to there. Metacarpal 5. So all the way down to the lobe of the carpus, from the carpus to the finger, is a metacarpal. The thumb is special because the first part of the thumb is the metacarpal and it can move. If someone can move, say, your first and second metacarpal, they're probably putting you in extreme pain, you know, like trying to dig their thumb in between anybody know what I'm talking about? Okay, let me try this again. I can move metacarpal 1 and metacarpal 2 apart. Ooh, it's not hard. Metacarpal 1, metacarpal 2 apart. Oh, easy, bring them back together, very easy. If I'm moving metacarpal 2 from metacarpal 3, someone's breaking my hand. Does that make sense? Does that make more sense? Okay. So, but these that are articulate on the proximal end of these bones. So these bones, their proximal end up here at the wrist, they articulate with the carpal bones. The distal ends articulate with the phalanges, the phalanx bones that make the digits. Good? All right? Now, in the digits, you're going to notice something. I'll put this back on in just a second. Every one of the fingers is going to have a proximal phalanx, a middle, this was the pointer, a proximal phalanx, a middle phalanx, and a distal phalanx. Good? So a finger has a proximal, a middle, and a distal phalanx. The thumb, this is the digit that's special. It has a distal phalanx, but this is the only other phalanx. The thing above that is a metacarpal. We just spent a long time talking about that. So the thumb has a proximal phalanx and a distal phalanx. Every one of the fingers has a proximal, a middle, and a distal. Are we good so far? All right, so let's see what we've got here. Metacarpals, we number them. The thumb would be 1, and this is important. Where it says, oh, you need to know these to be able to number them correctly. You see that in your study guide. They're not kidding. The reason they're saying that is because if I ask you the name of this bone, I would want you to say it's the proximal phalanx of digit number 5, or the proximal phalanx touching metacarpal 5. Does that make sense? You should know.
No, I did.
You get it? Okay, good. I'm like, I thought it was pretty straightforward. You're going to have to know which number is which. Because if I ask you, what is this? Don't say metacarpal, say metacarpal 5. Just be as specific as possible. If I ask you this, it's metacarpal number 3. 1, 2, 3. So the metacarpal above the middle finger is metacarpal 3. Are we good? All right, we have gone through the hand. We've done everything to the level, to the detail that we're going to do in the upper limb. Let's now move to the leg. And, you know, just like when we started with the leg, sorry, when we started before, we started with the scapula. We started with the shoulder girdle for the arm. We're going to start with the pelvic girdle before we get into the leg. So, coxal bones. These two things are coxal bones. Good? Each of the coxals is an ilium, a sticky uppy part, an ischium, that's a sticky downy part, and a pubis sticks to the front. It's easy to know the pubis is where the pubic hair would be, to the front. The ilium, I already used the example for you guys, Mickey Mouse makes me ill, the traffic, Disney is horrible, you remember that? Okay, so, let me turn these to be proper, I had them the other direction, but you guys remember I had said M-I-C, yeah, so the ilium, it makes you ill, okay? The ischium is the part that is sticking down. I'm holding this bone by the ischium. Here, let me do it this way. Okay. This, I am holding, let me zoom out. This coxal bone is made out of an ilium here at the top
an ischium at the bottom. I'm holding the coxal bone by the ischium, and a pubic bone that sticks forward. The two pubic bones meet. Let's turn this like that. Two pubic bones meet at the pubic symphysis. Are you with me? Okay. The pubic symphysis is one of the places in the body that we have fibrocartilage. Most of the cartilage in the body is hyaline. The pubic symphysis is one of the ones that is fibrocartilage. It's tough. All right. So we've done the three bones. This socket for the ball and socket of the hip, the socket is called the acetabulum. I want you to notice that the acetabulum, there is a suture line. Do you guys see a suture line here, a suture line here, a suture line here? What I'm trying to tell you is that this socket, this acetabulum, it's made out of all three of the coxal bones. They're fused together in that socket, in that acetabulum, and you can see the suture lines. Pick up the one. Does nobody have bones? Pause the recording and everybody get bones. Coxal bones made of ilium, ischium, and pubis, yes? Now let's talk about the parts of those. So the ilium, the sticky up part, you can see we need to identify the iliac crest. Well, that's the highest part, the top of the Mickey Mouse ear. Good? That's your iliac crest. Now below that, the acetabulum, and we already talked about that. That's the socket, yes? Okay, you can see the suture in it because it's actually formed by all three bones, just like it says on the list. Good? Below that, it says the greater sciatic notch. Right here, where my finger is. The bottom of that ear, we have this big notch, and below we have a point that looks kind of like a bird beak. We'll get to that. But this big notch, that's the sciatic notch, where the sciatic nerve goes. The greater sciatic notch, actually. Okay? The lesser one's below the point. So there are actually two parts. But if you wonder how big that notch, how big that nerve is big enough you need that size notch. It's as wide as your finger. Got it? At least I can't say, I've never seen a human dissection. I've done several horse dissections, and their sciatic notch is that big. Like it's wider than my thumb. Okay. Everybody good so far? We've done all three things in the ilium, yes? Okay, we're now going to do the pubis. The only thing they want you on the pubis is the pubic symphysis. I'm holding the pubic bone here. Remember, symphysis is where things come together. That's your pubic symphysis, where these things, let me flip over. This would be your pubic symphysis, where the pubic bones come together. Yes, good. All right, so that's your pubic symphysis. Now let's look on the ischium. First, we're going to do the ischial tuberosity. This big, thick, chunky area here that I'm picking the bone up by, that's your ischial tuberosity. Remember, tuberosity is big. It has a lot of texture to it. Usually like you're attaching muscles or tendons to it. That's your ischial tuberosity. Okay. The obturator foramen. Well, you know foramen means a hole. The obturator foramen is this giant hole that my fingers are going through right now. Okay? It actually is made up of the ischium on one side, the side by the tuberosity. On the other side, it's made up of pubis. So this is actually between the two. But this is important because, like the obturator nerve would go through the obturator foramen. I've asked that before on tests. I think it's good to use things that people have heard before, they understand how they're related. Kind of like, I already told you, this suture on the skull, the sagittal suture. I like that one because you guys had the sagittal plane as one of the first things you learned in the class, right? So it tends to make it easy. In the same way, because you're doing the obturator foramen, that's why when I get to nerves, I like to use obturator nerve. Does that make sense? So, but yeah, it's an obturator foramen. Let's keep looking. Lesser sciatic notch and sacroiliac joint. I already told you the greater sciatic notch is right here where my finger is going, yes? Well, you need the lesser one, and it's right there where my thumb is. The lesser sciatic notch is right here. Are we good? Yep. All right. And the sacroiliac joint. Since you now have your bones, I would like to, how many people found the lesser notch and were able to touch it? Okay, good, good. Let's see, it looks like everybody's doing the thing. All right, sacroiliac joint. Do you know what the sacrum is? The middle of the pelvic girdle. So let's take our sacrum. I'll put this on the screen so you can see it. By the way, this is one of the ones, a lot of people get the angles wrong. They don't realize how close, how good it is. These are actually pretty good models. So this is the sacrum, yes? This is a coxal bone, yes? Would you agree that this should be articulating with the sacrum, the sacroiliac joint? Put these together. I'm going to walk around so we can see it.
Is that the coxal bone?
Look at how well those are
Right.
together. They really do fit together. Yeah? You guys see it?
Here. Here's the other piece.
It fits together good. It's not, oh, it's all stitched together, Carlos. It's good. See it?
Oh, yeah.
Here, I'll show you what everybody gets wrong, gets off. People are like, oh, it doesn't really fit. No, if you rotate it right, it fits perfectly. Right like that. You see it? See what I'm talking about? Yeah, exactly. Very nice. Tight. Yep, exactly. And that's the natural rotation. That's the natural way it sits. Okay. So you agree we've got the sacroiliac joint, yes?
Whenever you finish, let's see.
All right. Let's see what we have next.
Wait.
Hey, it looks to me like we've got the coxal bones.
Like this?
We are ready for the leg. We're going to start with the femur.
Is that right?
Everybody good with that? Grab a femur to look at. All right. So here is our femur.
What is this thing? This is just chill. Right?
Everybody sees the femur, yes?
Yes. And then this.
Okay.
This too.
Here is the head of the femur. Good? Yeah? Head of the femur. It goes into the, what's the name of the socket? I'm looking for an A word.
Acetabulum.
Yes, the acetabulum. Very good. Now, we are going to look for below our head, we have a neck. So if this is the head, this narrow area would be the neck. You with me? Yep. So, head, neck. Oh, by the way, you see this little divot, this little spot on the head? It's called the fovea capitis. It is a spot where a ligament is attached to the head to help keep it in the acetabulum. Good?
What is it? Fovea capitis? I see it, but like, what does it do?
A ligament is attached there to help hold the head into the acetabulum.
That's it?
All right.
Fovea capitis. Phobia?
Now we need the greater and lesser trochanter. This huge piece sticking up right here, would you agree it's greater, it's bigger? This would be lesser right here. This is greater, this is lesser. The greater trochanter right here. No, that's a head. This is a greater trochanter. Yes, greater trochanter. This would be the lesser. Are we good? It's still big enough to pick it up by, but not nearly as easily as the greater trochanter. So, greater trochanter right here, lesser trochanter right there. Everyone good? All right. Now, look at this. The back side, well, I should say, how do you know which is which? How do you know which is the front and the back? Let's look right here. Pull this up for everybody. All right.
The wrong way.
Would you agree that we have condyles on the distal end? Yes?
Yes.
Yeah, no? Bueller, you guys